Now you can think of, suppose if I do the same experiment um, with, instead of plastic rod, if I if I carry the metal rod, and if I do the same experiment, will the result will be the same or not? So you can find it out. Let me tell to you, the result will not be same, because metal is a good conductor. So during the course of rubbing, the charge may produce, but your body is also a good conductor. So what happened? And the earth is a best conductor. So what will happen? Ultimately, the charge will flow through the earth. So no charge will stick longer if it is a metal conductor. Okay, so the process will not be successful in that case. So you will see mostly frictional electricity is true only for the bad conductors. Okay, now coulomb. Okay, now I'll directly come to the coulomb law. Coulomb, Coulomb's law. Okay, now if you do small experiments, then electricity, the force due to the electricity is more powerful than that of the gravity. This is quite clear, like even this, in this example also we have seen that that was attracted, right? So we can see that um, electric force is much stronger than that of the gravitational force. Coulomb basically studied about the forces existing on the charges and how they exert force on one another. We will start with point charges. Suppose here is a point charge. You listen this one carefully. Suppose I have one positive charge, let's say for Q1, and here I have another point charge. We will start up with the point charges. See, this is also plus. Okay, now say they are kept at a distance of r away. Then Coulomb say that this they will exert repulsive force on each other equal in magnitude, and that force is directly proportional to the product of their charges, and that force is directly proportional to the 1 by square of the distance between them. Okay, let me repeat. The repulsive force in this case, if this is negative, then that will be attractive. So in this case, the repulsive force is directly proportional to the product of the charges, and inversely proportional to the square of the distance between them. And what will be the direction of the force in this case? Because force itself is a vector quantity, so the this force Q2 will be exerted along this direction, right? And Q1 will be exerted along this direction. See, force is a vector quantity, so we need to treat them in the form of vector. Okay, though the magnitude of the forces are the same, that means the arrow have to be the same. Then if we combine these two, here in this formula I am just taking them in terms of magnitude, so I am not putting any vector sign overhead. So when they are combining against each other, then what will happen? This Q1 Q2 by r square. Okay, now the direction, repulsion. Okay, so about whom we are telling the force, later on we will see it. Now whenever this proportionality is changed by an equal to, then what will come? There comes a constant, right? This constant depends upon the medium. Okay, and this, so many books have represented the force Coulomb. This is the expression of Coulomb force. Okay, now we can find little bit similarity with the gravitation also. In gravitation, the character was masses, right? Isn't it? The character was masses m1 and m2, distance r. So what is this? Is equal to g m1 m2 by r square, right? Now this was a constant, but this constant was fixed in number. It do not depend upon the medium. However, this depends upon the medium. So keep in your mind that this k depends on the medium. Okay, and this k, it's easy to write this way. However, this k is equal to 1 by 4 pi epsilon naught. Later on we are going to discuss about it, and this is just a number. This is equal to 9 into 10 to power 9 Newton meter square per coulomb square. You don't need to remember this one. Okay, so this k is a very big value. Okay, like compare g was 6.67 into 10 to power minus 11. This is very small, while this is very big, right? So which itself shows that this what to say, electrostatic force is a strong force, while gravitational force is a weak force, right? So I can write this way. At this moment I don't want to talk anything about that. Just remember k is a number, and this is equal to 9 into 10 to power 9 Newton meter square per coulomb square in air or in vacuum. Okay, if the two charges are in other mediums, then the value will not be this one. So please bear in your mind this part. Okay, now then I hope this is clear, right? Okay, so this is Coulomb's law. Now as I have said, force is a vector quantity. So can we treat them in the form of vector? Yes, we can treat them in the form of vector. Let us see it. Okay, there is a small way of doing it from the in terms of exam point of view. This is important, so let me do it. Okay, now let us use some conventions. Okay, like let's say this force q2, on q2 what force is acting? F, right? How much F is? F is nothing, just k q1 q2 by r square. Even for q1 also the force is the same, but for q2, in what direction the force is acting? This direction. This direction doesn't make any sense. We have to name it. So let's call this direction as F21. I hope we understand it. F21 means what? The force on 2 due to 1. While let's call this one F12 means what? Force on 1 due to 2, right? Force on 1 due to 2. Here's have to be square. Okay. Then F21. Now we need to, this direction, let us call the direction, let's call this direction this direction is x dash direction, and this direction as this is x direction and this is x prime direction. But we will not use that. We will use in vector, we use the unit vector, right? So let's call this is r21, means it represents the positive x-axis, and this the unit vector is represented by overhead cap, and this direction is r12. Okay, fine. Okay, is it clear? Now let us go for individually F21. Okay, F21 vector, that is force on q2, right? Vector is the totality of the magnitude. What is the magnitude? You can use any, you can write magnitude is k q1 q2 by r square. And what is the direction? The direction is positive x-axis. What it is, we are assigning it by unit vector, this one. Okay, I hope it will be clear to you, students. Then similarly, F force on q1, the magnitude is the same. I'm repeating it, student. So that is K Q1 Q2 by R square, right? And what is the direction? X prime is the direction, and this is what? 1, 2 prime. Sorry, gap. Okay, now this K is 1 by 4 pi epsilon for air or vacuum. Normally we use air and vacuum for it. That is 1 by 4 pi epsilon Q1 Q2 by R square, R21, and here also I can write it 1 by 4 pi. This is just a number, 9 into 10 to the power 9, for air and vacuum. I'm repeating it again and again. Okay, so this is R12. Okay, all right. Can I call this equation number 1? Can I call this equation number 2? Okay, now unit vector. Okay, any unit vector, basically unit vector is, this is what it is, a vector divided by its magnitude. In class 11 we have learned about it. I hope we are still remembering it, student. Unit vector is vector divided by its its magnitude, right? Okay, now okay, now equation 1, if we see it, equation 1, how can I write this one? Equation 1, this is F21, this equal to 1 by 4 pi epsilon naught Q1 Q2 by R square, right? Then in place of unit vector, what I can write? Vector, that is R21 vector divided by its magnitude. Magnitude of R21, the magnitude of R21 and R12 is how much? The separation between the two charges. Hence, this is R. So, then this will be how much? This equal to 1 by 4 pi epsilon naught Q1 Q2 by R cube R21. Okay, similarly I can do for F12. Okay, this is 1 by 4 pi epsilon Q1 Q2 by R square. Then for R12 I can do the same. This vector is what? R12 vector divided by its magnitude is how much? R. See, we need to know the difference between magnitude and vector. Okay, so this is 4 pi epsilon naught Q1 Q2 by R cube and R12. I have given this one in your notes. You can refer the notes for that. Okay, now the direction of R21 and R12 is entirely different. I'll show this one. Then this will show, this implies, if you see it properly, the direction of F21 and F12 is different. Means what? F12 is equal to minus or F1 F21. Please have a look properly, students. Look through your notes. I hope you will be able to understand that.